What is a Kruskal Wallis H-test? A Kruskal Wallis H-test is used to determine whether three or more groups' medians on the same continuous or ordinal variable differ. This is a non-parametric test. It does not assume normality of your group, so you do not have to meet this typical bell-shaped curve. And if you're looking for additional help running a Kruskal Wallis test, we have the U of G SPSS LibGuide, the Layered Statistics Guide, and the SPSS documentation to help you with that. What are the assumptions of a Kruskal Wallis H-test? We have 4. The first is that your dependent variable must be ordinal or continuous. The second is that your independent variable must be categorical with 3 or more independent groups. The third is that your data must be independent. And the fourth is that the data distributions of the 3 or more groups that you have must have the same shape. This one's a little bit new for us, so we'll cover that in the next few slides. Let's go. So our first assumption is that the dependent variable you were using must be ordinal or continuous. Here, if we look at fake data 1, we can see this has a range of values. It's got some decimals. It's a giveaway that this is a continuous variable. So we've passed assumption 1. Assumption number 2 is that you must have a categorical independent variable with 4 or more groups. We can look at our color column here and say each participant can say, for example, their favorite color. They have 4 options: pink, blue, green, or orange. They are independent groups because each participant can only pick one. And it's categorical because there's only those 4 options, 4 different buckets. So we have passed our second assumption, the categorical independent variable. Our third assumption is a little bit hard to check after the fact. We normally set up this assumption before we run the test. So when we're checking the assumption that the data must be independent, if we're trying to do it after the fact, we can look at each row of data and say, does this look like a unique participant, for example? So here we have participant number 1. They identify as male. They have data for fake data 1, 2, 3, and 4. They've listed their favorite color as pink, and they're in the small drink group. So it looks like the data are independent because it looks like everyone is a unique person. Hard to check this one after the fact. This is fake data. We're just going to say this one passes today. And then our last one. This one's a little tricky. So this is for each group that you have, the distribution of the data must have the same shape. I'm going to shortcut us here a little bit. There are other ways to make this graph, like through the chart builder, but we've actually already seen these histograms in the one-way ANOVA portion of today's lecture. So I'm going to just drop them for you here. What we're looking for here is each of these graphs should approximately look the same. They don't have to be perfectly identical. You don't need the exact same number for each bar, but you want to look at these and say, you know, if it approximates our normal bell-shaped curve, for example, all 4 of them should do that. Here we see, for example, for histogram color orange, it's highest on the left, lowest on the right, whereas for histogram color green, it's highest in the middle, lowest everywhere else. Histogram pink, highest on the left, lowest on the right. Histogram blue, kind of highest, mid and right, lowest on the left. Does this pass? It's tricky. We know based on our one-way ANOVA section that we've already done that statistically, these all pass normality. So statistically, we can say, they're probably similar enough. But visually inspecting, it's a little hard to say. Maybe this passes, maybe this doesn't. So this is your reminder to always check your assumptions because you don't know until you check. And in a case like this, it might be a little tricky to be able to say, are these the same shape, or maybe they are a little bit different. So always check your assumptions. It may or may not be appropriate to run the Kruskal Wallis H-test on this data. Assuming you have passed all of your assumptions, you can then proceed to conducting the Kruskal Wallis H-test. You do that by clicking Analyze, Non-Parametric Tests, Independent Samples. And this is an example where SPSS kind of hides what you're trying to do. So you should think to yourself, what test was I trying to do before? Right, one-way ANOVA that has 4 independent groups for this. We're going to look for the non-parametric version that does independent groups. Where is that? Analyze, Non-Parametric Test, Independent Samples. It's hidden a little. You click that, it will open up the non-parametric tests, 2 or more independent samples dialog box. There are 3 tabs here, and you need to click something in each tab. In the Objective tab, which opens by default, you need to click Customize Analysis, and then click to the Fields tab. In the Fields tab, you're going to take your continuous dependent variable from the left and put it where it says Test Fields. You're going to take your categorical independent variable from the left and put it where it says groups. Then you have to remember to click the Settings tab. On the Settings tab, you want to click Customize Tests. And you want to make sure you tell it which test you're trying to run. You were trying to run the Kruskal Wallis one-way ANOVA with K samples, K just meaning some number. And multiple comparisons, you'll probably want it to say all pairwise. When you're ready, you click Run. And if you do all that, you will get an output that looks like this. It's a little bit smaller than some of our other outputs, which is kind of nice. The top table is the hypothesis test summary table. This tells you what your null hypothesis is in words, what test you ran, the significance value of that test, and what decision you should make. So the significance value can be found in the hypothesis test summary table at the very top and a little bit lower down in the independent samples Kruskal Wallis test summary table. It's the same p-value. So here we have a value of 0.910. We fail to be able to say whether these groups are different from each other. And we should also get a graph if we scroll down. It says independent samples Kruskal Wallis test. It gives you a box plot. It's giving you a box plot because the Kruskal Wallis test uses medians. So box plots are the best way to show medians. If you have run this test and your p-value is less than 0.05, it means you found statistical significance between your groups, but you don't know where. Here, we would stop because our p-value is greater than 0.05. We did not find statistical significance. We would normally not follow up with additional testing. If we pretend there are differences between our groups, if we pretend we had p-value less than 0.05, we would scroll down in our output to the pairwise comparisons table. And then we'd be able to look here to say, is the orange group different than the green group? What's the p-value? Is the orange group different than the pink group? What's the p-value? Is the orange group different than the blue group? What's the p-value, for example? So today we wouldn't look at this because our p-value for the actual Kruskal Wallis test is non-significant. And that is how you run a Kruskal Wallis H test.